Hey guys, welcome back to MathScube. Today we are solving a physics paper that's from International Advanced Subsidiary Advanced Level, Unit 1 Mechanics and Materials. As you can see, that's a fresh paper from 2021, this year only, and we'll be going through the MCQs only from this paper. So without further ado, let's get started. So the first question is, a car is moving towards a stop sign at a speed of 25 meter per second. The driver applies the brakes 20 meter before the sign and deaccelerates uniformly to rest just before the sign. I'll just highlight some uh, important points here. And they ask us that which of the following gives the magnitude of the car's deacceleration in meter per second square. So we have to find out the deacceleration. So we'll use Suvat equations here. But which one? It depends on you. But I'll be using, so the purpose of using this v square equal to u square plus 2as is because um, I have my initial speed and I have the distance, that's s, and I have the final speed, that's rest, and that's equal to 0. So v equal to 0. So the final speed is 0 meter per second, and our initial speed is, they say the car is moving toward a stop sign at speed of 25, and that's our u. So our u value is, wait a second, that's 25 meter per second. So and now we have to find the a value. We also have our s value, which is, they say the driver applies the brakes 20 meter before the sign. That means the distance. So our s is 20 meters. There you go. And when I plug in the values, it will look like, there you go, 25 square plus 40a. And the next thing I want you guys to explain is, if we are finding acceleration, we'll keep this sign that's positive here. But if you're finding the deacceleration, what we'll do is we'll just remove this sign and add minus sign there, because deacceleration is the negative of acceleration. And now what I'll do is I'll add minus, you can say positive 40 on both sides, so we will get 40a equal to 25 square. Now, in order to get a, and they say the deacceleration, what I'll do is basically I'll just divide both sides by 40, and now you can check within your answers or the options A, B, C, D, that which is your answer, and we can clearly see that C is our answer here. Now moving on to the second one. The second question is, an object of mass 8.2 kg initially at rest falls a vertical distance of 25 meter through the air and has a final velocity of 20 meter per second. Which of the following gives the energy in joules dissipated by the air resistance? So initially, we have kinetic energy, that's K and E, kinetic energy written that way, and we have a potential energy too. So they ask us to find the dissipated energy in terms of air resistance. So you can say 8.2 kg. For potential energy, the formula is mgh, which is mass into gravity into height. And for kinetic energy, it is half mv square, where m is the mass and v is the speed. Now the reason A can't be our option is because it only accounts for potential energy and not kinetic energy. Why? Because it is falling a vertical distance of 25 meter. It means that the potential energy is decreasing. Whenever something falls down to the ground, its kinetic energy increases and potential energy decreases. So A can't be the option. If we talk about B, they are adding the both of the terms, at kinetic energy and potential energy, that we don't want. We want the dissipated energy, which means the difference. So what we'll do is we'll subtract here. So we will subtract here. So we can see that clearly that our option is C, that's being subtracted. Moving on to the third question. The graph shows how the acceleration A of an object varies with time. T, okay, that's acceleration time graph. And they say which of the following graphs show how the velocity v of the object varies with t. That's a pretty basic question. You should have knowledge about the graphs. Uh, it's pretty easy. It can't be C. You just have to see and mark out the options that are false here. It can't be A. Now we are left with B and D. Now the reason B can't be the option is because B is decreasing, and we always are being learned that the velocity time graph is opposite of the acceleration time graph, which is going in the other direction, increasing. So we can say our answer is D here. So the fourth question is, a student measures the time t taken for a ball bearing to fall different measured distance s from rest. The student uses his measurements to plot a graph with gradient equal to the acceleration due gravity g. Which row of table shows a graph with gradient equal to g? They have given us a column of y-axis and an x-axis. So what I recommend you guys is always draw a Suvert diagram, or you can say write down the Suvert equations. Always remember, students, that whenever they say or whenever they mention g, s and t, the only Suvert equation can be written is s equal to ut plus half at square. Now to make your life easier, they say that the student measures the time taken for ball bearing to fall different measured distance. So our initial speed, you can say, will be 0. So when our initial speed will be 0, this thing will cancel out because that will be 0 into t, that will give us nothing. Now we are ultimately left with s equal to half at square. Now to remove the fraction, I'll multiply both sides with 2. There you go, guys. We have formed our, or you can say this has begun to take a form of linear equation. I'll write it now. There will be y equal to mx plus c. Now if you guys remember, always the ball bearing or any, if you're finding the gravity, the graph will be a linear one. So it will be starting from origin and be a linear one. It will be a straight line graph. Sorry for this rough line. That will be a linear graph. So the c will be 0, and so we are left with y equal to m of m and x. So we can see clearly that t square is our x and 2s is our y. So we can see y-axis 2s and x-axis t square. So B is our final answer. Moving on to the fifth part. So the fifth question is, a student is investigating a material in the form of wire. Which of the following properties of wire will change if longer wire is used? So if we look at the options here, A, breaking stress. Now breaking stress is the property of a material, and if you remember, a wire has its own dimensions, so it's independent of it, so breaking stress cannot be our option. Moving on to the B part, density. It is a product of mass upon volume. So if the mass gets bigger, or you can say gets larger, its volume will go up too. So that's m, that's going up, and volume will go too. So that doesn't happen. So density is not our option. Moving on to the C part, stiffness. We can consider stiffness. Now stiffness is the ability to change if we withstand a higher loads on the wire. So stiffness is the property that can surely change, whereas Young modulus is independent too. So stiffness can our answer. That's our final answer.